Yeah. So yesterday we have seen about PostgreSQL.conf, and today we'll see practically how we can change if we want to do any parameter changes. And before changing that parameter, how we can identify whether it's a static or dynamic. And if it is a dynamic, how we can change. If it is a static, how we can change these parameters. Okay. So as discussed, pgtune is one of the best tool to analyze the parameters in the initial stage of your cluster build. So whenever you build any new cluster, we have to keep in mind first we need to change the password of Postgres user, because Postgres user doesn't have any password. We have to change that, and then we have to allow the client connections. That is the second point. And also we need to change and set the necessary parameters based on your system resources. That is the third point we need to keep in mind. And then we have to configure backups. And if you want to have a replication, so you can set up replication based on your requirement. This is how we can handle. Okay. So my cluster is up and running. So I'm just connecting to pSQL. Now I want to, for example, I want to change shared underscore buffers. Okay. So currently I have shared underscore buffers 128 MB. This is the default value whenever you build any new cluster. Okay. We have to change this value based on our memory. So recommended value is 25%, right? Which pgtune also give the same value. Okay. So now I want to know whether this parameter is a static parameter or dynamic parameter. So I want to just go to pg underscore settings, Here I will find name, settings, and context. Okay, this is the main important where you can find whether it's a static or dynamic. If you see here context equal to postmaster, then it is static parameter. Okay, you require a downtime. And if you see that as a SIG hub, okay, then that is a dynamic parameter. For example, I want to see for work underscore mem. Okay, so I want to check whether this is a static or dynamic. I'm going to check this. Sorry. Okay, context equal to user. So user is user and SIG hub. Okay, this all, let me first list what are the context. Okay, we have these many values of the context output. So one is postmaster. Postmaster is, this is a static parameter. If you see any parameter as a postmaster, this is a static parameter, and remaining all is almost a dynamic parameter. And if you see something SIG hub or user or super user, okay, or backend or internal, these are the mostly dynamic parameters. You can change. Once you change, you have to just reload your configuration. That's it. So it will reflect immediately. Okay. And if you see postmaster, then this is definitely a static parameter. You require a bounce back. If you see any other things, then this may affect after your reload of your configuration. Okay. Now I want to change my parameter for shared underscore buffers. So either you can do with alter system set command, or you can also do with directly. You can go to postgresql.conf and you can directly edit it. Okay. So first let's go and do in postgresql.conf. So postgresql.conf will be under pg data. Okay. So we have postgresql.conf. Okay. And I'm just going and searching this parameter. So this is 128 MB. I'm going to change to 150 MB. I'm just saving this file, and okay, so just see whether it is changed or not. It will not change, right? Because this is this we have seen. Okay, this is a static parameter because the output of shade buffer in pg underscore settings is postmaster. Okay, let me, instead of restart, let me try to reload and see if it is affecting. So reload we can do in two ways. One is pg reload underscore conf. This is one way. And other way is pg underscore ctl reload -d $pg data. So either way you can do. If you change any dynamic parameter, you can just reload it. Okay. So reload is also done. Okay, so I'm just going and checking whether this parameter is reflected or not. Still it is not reflected because this is static parameter, right? Because the output is postmaster. Okay. Now, since this is a static parameter, we have to restart our cluster. pgctl restart -d $pg data. So either you can stop and start, or either you can do restart. Okay. So restart means it will stop and start. And here I'm not mentioning any -m option, which means by default it will go which method? So which is the default method for PostgreSQL? Stop.
Fast.
Yeah, so it will go with the fast method. And since it is restarted, I am going and checking in again this parameter. So it is reflected. So this is how you can change the static parameters. Once you change the parameter, you have to reload it or restart it. A reload will not work for static parameters. Okay. This is one way of doing, and let's go and check for work underscore mem, how we can change. Okay, so this is user. Okay, if you see user or most of the parameters, you will see, if it is a dynamic, you will see SIG-hub or user. Okay, so let's go and change this parameter, work mem. So I'm going same PostgreSQL.conf. Let me do reload. I have changed from 4 MB to 10 MB. Okay, so I'm just trying to do a reload and just check that parameter value. Show it is immediately reflected to 10 MB because that is a dynamic parameter, and the context output we see as user or SIG-hub. Okay, and if you see that it is a dynamic parameter, you can just do reload and the new value will be reflected immediately. So this is how we can change in PostgreSQL.conf directly. Okay, so this is one way. And since this PostgreSQL.conf is a very sensitive file, let me try to, for example, for example, I'm trying to change some parameter and maybe, so by mistake, I've given some special like Jing character, okay? So let me go and try and restart my cluster. So it is telling could not start the server. Go and check your error is redirected to log file. Go and check in the log file what is your error. So if you just go in the alert log and you just identify the issue, what exactly it is telling. Could not translate host name I2 start. Okay, and if you see, even this is not mention any specific parameter also. It is just telling this particular I2 star is not able to read, okay, from the parameter file map from the PostgreSQL.conf. So few times, okay, so few times you can identify easily, but few times a very small Jing character also, it's very difficult to identify because it's a very big file. So whenever we are changing, anyhow we are taking a backup, but still few times this may, okay, these things may happen in real time. Okay, So whenever you are changing this, we should be very careful and we should have always a backup. So you can just take backup with a copy command underscore backup, or with today's date. You can just take one copy of backup, okay, with a copy command. So now let me go and change that value. So if, because of that one gen character, your entire cluster may go down. Okay, so we should be very conscious whenever you are changing this parameter directly. And so that is the reason they have introduced, instead of going and editing every time, they have introduced one more parameter called PostgreSQL.AutoConf. Okay, so for now, no parameter is added in the AutoConf. Okay, here you could see, do not edit this file manually. It will be overwritten by alter system command. So you should not go and add the parameters here. Okay, we should always do with alter system set command. Okay, let's go and do one parameter. Maybe we can take shared underscore buffers. Okay. I want to change the shared underscore buffers from 150 to some 200. Okay, I'm going and doing with alter system command. Same alter system set parameter equal to value. You don't have like scope equal to something. Okay, so directly we can change this. And we know that shared underscore buffers is, or okay, let's go and change max underscore connections. Okay, by default, it will give 100. So I want to change this 100 to 200 or maybe 500. Okay, alter system. Before that, I want to check whether it's a static or dynamic, right? So let me go and see whether it's a static parameter or dynamic. Max underscore connections. Okay, so it is telling it's a postmaster, which means it requires bounce back. Okay, and also I want to check few more details here before I do. Let me go and take select name, comma, source, and I also want boot value, and I also want the source file. This is important, and whether it's really required pending restart. Okay, from pg underscore settings, where name equal to max underscore connections. Okay, so this is my parameter, max underscore connections, and it displays, this is a configuration file. And if you see, currently it is reading from PostgreSQL.conf, and whether this parameter requires a pending restart or not. Okay, it will display here. If you are already, this parameter is already configured with auto.conf, it will tell that this is a source file, it is ready. Okay, for example, I'm changing my max underscore connections from 100 to some 200. Okay, and I'm just trying to do a reload. Okay, and if you go and see that parameter, still will not reflect because this is a static parameter, max underscore connections. Still it is not reflected. Now let me go and see the same output. Okay, so here it is telling pending restart. Okay, still it is reading from PostgreSQL.conf. If you go and see PostgreSQL.AutoConf, you could see an entry is made already in auto.conf, but still a restart is pending. Okay, since it is a restart is pending, it is still reading the old value, which is 100. Even though you have in the auto.conf, it will not reflect immediately because you require a bounce. So whenever you see pending restart, which means you have changed a parameter, but that to reflect that value, you require a bounce back or restart. So let me go and do a restart. And okay, now you see it is reading from auto.conf and pending is false. Okay, so this is how
What
you
is
can.
it about boot underscore wall column, Suresh?
This is just a value.
Previous value?
Yes, this is a previous value. Means whenever you boot, I mean, whenever you initialize the cluster, what is the value? That time it will show that.
Okay.
We can say whatever the initial value. Okay. So in auto.conf we have latest value. Okay.
If we change the value again to 300, now the boot value shows 100 or 200.
Yeah, it will show 100 only. Let's do that.
Okay.
For example, I think whatever the value which it has in PostgreSQL.conf, I think it will reflect. It will show that, I guess. So let me restart. Yes, still it is. That is saying, I mean, boot value means whenever we are initializing the cluster, whatever it has, it will show that.
Okay.
Okay, now it is 300. And even you could see PostgreSQL.auto.conf, it is added as 300. But if we go on seeing PostgreSQL.conf, okay, it is 100. Okay, which means whenever you do any parameter with alter system side command, it will not update in the PostgreSQL.conf. It will only update in the auto.conf. And whenever you start your cluster, first Postmaster will read from PostgreSQL.conf all parameters, and also it will read auto.conf and it will check for any new version of parameters is available. Whenever it has a new version, then it will take that value. Okay, for example, here we see it is picking from auto.conf because that parameter we have in auto.conf. Okay, this is how you can verify, and you can just check whether this particular parameter is, I mean, source file is whether auto.conf or whether it is a conf. So this is how you can change any parameters, okay, whether it's a static or dynamic. Okay, and so for example, so if you want to change any parameters, as discussed, parameter is at the cluster level. Okay, so few times you may require to change at session level, or maybe few times you may require to change at database level, but not like frequently. As discussed, whenever you are doing any complex operation, okay, that moment you may require it. So even in Oracle, you may do, you will allocate some parallelism or something, right, with the alter session set. Maximum parallel process you will assign, right? In similar way, if you want to do a parallel process, or if you want to allocate any particular memory, okay, maybe we can also do at the database level. For example, I may just do 200 MB. Or 20 MB.
In capital letters.
Yeah, so I'm just checking what I did in previous, because it Max underscore connections. Okay. Yeah. So since this is a dynamic parameter, I'm just trying to reload it to effect before that I will also check it is still 10 MB, and I'm trying to reload it just with select state. Okay.
So you have set it for database, right?
Yeah, I'm currently in the same database. Okay, let me connect again. Yeah, maybe for that particular session, I think it's, it hasn't reflected. So it's reflected, but if you see and if you go and check in the Postgres database, it is still 10 MB because we have only set this 20 MB for this particular database. Okay, SkyOps database. Okay, like this you can also set at the database level, and then later you can, again change to the old value from the database level as well. Okay? And let's go and see whether it is reflecting at PostgreSQL.auto.conf. If you see, whenever you change any parameter at the database level, you are not able to see in auto.conf because it's only manage at the cluster level. Okay, so database level and session level is temporary, right? We allocate based on our requirement. So that is the reason it won't add those values in auto.conf. Okay, so you have to remember. So whenever you change any parameters in database level, that entries will not able to see. Okay, so we have to very conscious, very careful whenever we are changing any parameters at the database level and session level. We have to remember and we have to roll back to the previous value. Anyhow, we are checking at the cluster level what value we have. We can roll back to that particular value. Okay, so but you don't see that entries in auto.conf whenever we change at the database level. Yeah. So any questions up to here?
Yeah, I have one question. Now, for example, work_men can be set at database level, at user level, and at session level also, right?
Yes.
So as a DBA, how can I query what are the workmen settings at these levels?
Whatever the parameters which is at the user, so whatever we see in the context as a user, right? Or whatever you see, okay, let me query this again. Okay, so whatever you see at the user level, okay, or super user level, most of the parameters can be changed at the database level or session level. Okay, even I think you can also change with SIG-Hub, but whatever the parameters which you see, the remaining things like postmaster and backend or internal, probably few parameters it won't allow to change at the database level. For example, if you see shade underscore buffer, so let's say shade underscore buffers, okay, whether it will allow or not. Alter database. So these dynamic parameters, it won't allow to change. Sorry, these static parameters. Okay, I'm going to change to some 180 MB. Parameters shade underscore buffers cannot be changed without restarting the server. Okay, so which means it will not allow actually to change few parameters even. So for example, shade underscore buffer. Okay, so this kind of parameters it won't allow. So let me restart. Even if you restart, so it will tell like this only. Okay, so it won't allow. So based on this, context distinct value, okay, you can query. So whether that parameter belongs to postmaster, you cannot. If it show user and super user, okay, at least it will allow to change. So that list actually I will share you, okay, after class, whatever the parameters which.
But related to, I think Darpan, you asked like.
Yeah. I will let me rephrase my question. So yeah, for example, we set some value at database level, right? Or user level or session level. So that value you can't fetch from auto.conf, right?
Yes.
So what is the dictionary view where I can see what are the settings? Because
Actually,
for example,
yeah, got it. Yeah, that one, like actually there is no direct views to check those values at database level or session level. Okay, so we have some catalog views here, like it's a combination of catalog views, not like direct view you have. Okay, so we can pick from pg underscore catalog pg underscore db underscore role settings. Okay, it is, yeah. So that way we can fetch whenever if you perform any changes in the database level, you will get it, those things.
Okay, because
yeah.
See, there is a setting at database level, right? So I need to be able to...
Got it. Totally. Your question totally got it. But there is no direct view in the PostgreSQL. Okay, you need to combine the PG catalog view with another catalog view, like that is like PG underscore DB underscore role underscore settings. Okay, based on that, we will get that information. Okay, we will provide you exact command. Okay.
All right.
Yeah.
Okay. So at that particular database level, even it will reflect to PG underscore settings, but it won't reflect to any auto.conf or PostgreSQL.conf. Okay, for example, let me run the same. Okay, here it is showing 10 MB. Here it is showing 200 MB. So it will, you can see with this, but you cannot able to find out there. Okay, because you got right at the SkyOps, I have set to 20 MB. Okay, but the remaining, like all the remaining databases, you have 10 MB. Okay, so now we can also check PG underscore file underscore settings. We also have other view. Okay, with PG underscore settings, this will give still summary information of all your parameters, whatever you have set and whatever is enabled. Okay, so these are the parameters which is already enabled in my PostgreSQL.conf and auto.conf. Okay, and you could see here this parameter is taking from PostgreSQL.conf. Okay, and even it will also display the previous versions. Okay, see max underscore connections we have set from Alta system set. So first it reads from here, and first it reads all parameters from PostgreSQL.conf. You see here, and later it will also read from auto.conf. So this value is a new version. So it will take this new version value. So any questions up to here? Yeah, as as Ross said, like we can also able to find out, okay, from PG underscore settings and PG underscore DB underscore role settings. Okay, we also have the other view. Okay, either from any of the view, we can able to identify that value. Okay, if you change at the session level or database level, we can able to find with the two views, PG underscore settings, PG DB role settings from PG catalog table. So that we will provide in the lab manual also, so that you can you can try to practice. And now what I will do, I will try to just do alter system reset. Okay, so if you want to reset a specific parameter, you can just reset. For example, I want to reset max connections. Since I have only one in my PostgreSQL.autoconf, I will just do all. So if you do this command, so alter system reset all, okay, what will happen? You can just go and say in PostgreSQL.auto.conf. So it has deleted everything, which means you are resetting all parameters back to your previous version, which is there in the PostgreSQL.conf. Okay, so now if you restart your cluster, so you could see now show max underscore connections. Okay, it is reflected to 100 back because I have already reset with alter system reset command. If you want to reset a specific parameter, you can just mention that parameter. It will reflect, for example, max underscore connections, alter system reset max underscore connection. It will reset only that particular parameter. If you have more parameters in auto.conf, you can only reset a specific. Since I have only one, I just given all. Okay, it will remove from all parameters to auto.conf, and it will read everything from PostgreSQL.conf. If you see now, there is no parameters from auto.conf. It has read all parameters from PostgreSQL.conf. Okay, so this is how you can manage the parameters if you want to change any parameters. So as discussed, before you change any parameters, especially in production systems, you better to take both parameters, PostgreSQL.conf and auto.conf, because you have to manage both the files. Auto.conf is just a new version of your parameters, and you can view from pg underscore file underscore settings or pg underscore settings, whether it is picking from auto.conf or conf. Okay, and that respective value you can pick. Okay, so this is how you can change the parameters. Yeah, Raj, please share your screen for table space.
Yeah. That's the wish.
Yeah.
So are you able to see my screen?
Yeah.
Okay, just I'm putting slide mode. Now you're able to see my slide mode.
Yes.
I'm moving the slides.
Yeah, we could be able to see.
Okay. Okay, right, guys. Our next module is table space management. Okay, so this is the agenda for table space management. We will start with logical structures of the database cluster and physical structures of the database cluster. And then we will get into the table spaces in PostgreSQL. Then after we will cover the OIDs. Okay, so from the beginning of the class we are telling database PostgreSQL database is a object relational database management system, and also here we are telling from beginning. Okay, so in PostgreSQL, each and every component, every component of the PostgreSQL, we can have a unique identifier, that is OIDs. Okay, so today we are going to cover about the OIDs. What is the OIDs? Of the database? What is the void of the table space? Okay, so what is the OID of the table? Okay, what is the data file here? Okay, everything will cover today. Okay, so with this module, okay, based on the time. Okay, so then we are going to cover about the FSM VM. Okay, what is the FSM and what is the VM? What is the free space map and what is the visibility map? What is the use of these particular two modules? Okay, and next thing is we are just giving the one slide. Okay, what is the difference between the Oracle and PostgreSQL related to table spaces? Okay, and once this table space management is completed, there is an interesting topic. Okay, that is a page layout. Then after toast, okay, what is the toast tables and what is the padding in PostgreSQL? Okay, so this may be tomorrow or maybe next Monday class, we will cover the internal layout of the page. Okay, it is very interesting topic, guys. Okay, so I think maybe what we can do, we can draw the diagram from the paint. I think that will be the better understanding for you guys. Okay, let me reshare my screen with the paint. Okay, or maybe this way I will share entire screen. Yeah. So guys, were you able to see my screen? I opened Paint. Guys, anyone can confirm?
Yes.
Yes, yes.
Okay. Okay. So we discussed, right? So the directory layout, how the directory layout of the PostgreSQL. Okay. So just I will read rather the same diagram. Okay. Not like complete diagram, but relevant to table space. Okay. So suppose, okay. Okay. Oh. Guys, we are poor in like painting. Don't mind. Okay. Okay. This is my, okay. I will draw okay, like this. Okay. This is my PG data, or maybe we can call it as a like base directory, master base directory. Okay. And inside that, we have sub base directory. Okay. And also, like this is one directory, and also we have a lot of directories and also a lot of configuration files. And then we have one more directory, that is the PG underscore TBL SPC. Okay. Okay, guys, actually here in PostgreSQL, we have the name table space. Okay, but the table space concept in PostgreSQL is totally different. Okay, compared to Oracle, maybe like if you all are from Oracle background, it is totally different. Okay, compared to Oracle. Okay, how it is different we can see. Okay, and first thing is there is no data file concept in PostgreSQL. First thing. Okay, so but how the data, okay, how the data file or the equivalent file will be here in PostgreSQL, you will get the better understanding after completion of this particular course. Okay, but this you can see, right? The base directory we have and some other subdirectories we have on configuration files, and also we have the another subdirectory that is a PG underscore table space. Okay, we are discussing, and this entire like table space management we are playing with only base directory and PG underscore table space. Okay, so we have relation is something like this, and we have relation is something like this. Okay, and the next, okay, so this is the base directory and this is the table space directory. Whenever in PostgreSQL, if we are creating any table, okay, and if you are creating any indexes, okay, so in PostgreSQL, we are telling there is no data file concept, okay, but in PostgreSQL, the data files or similar files, okay, will be created for each table, okay, for each table and for each indexes, okay, right? It is clear. So whenever if we create any table, or whenever if we create any like indexes, okay, the table file or maybe data file, okay, data file we are just mentioning just for your understanding, data file, table file, and real file node. Okay, all three terminology, all three words are same in PostgreSQL. Okay, that is equivalent to Oracle data file. Okay, so guys, I'm repeating again. Okay, in PostgreSQL, if we create any table, if we create any like indexes, okay, so the PostgreSQL will create, okay, each table having their own table file, okay, each index having its own table file, okay, and like how it will be created and what is the size of that you will see in like our slides. Okay, so suppose and also here in PostgreSQL we have maybe not two, I think we have three types of table spaces. Okay, this way I will tell you. Okay, the three types are, first one is PG underscore default, and the second one is PG underscore global, and third one is custom. Okay, guys, in PostgreSQL, I'm like here we are discussing about the like on-prem databases. Okay, so what is the like cloud databases? We will give just basic information. Okay, if you're talking about the like on-prem databases, okay, we have the three types of like table spaces in PostgreSQL. The first one is PG underscore default, and the second one is PG underscore global. The next one is custom table space. Okay, so custom table space is a customized table space. Whenever if you initialize your cluster, okay, whenever if you create your PostgreSQL cluster, okay, by default, these two table spaces, okay, PG underscore default and PG underscore global table spaces will be created, okay. So the PG underscore global table space, okay, it is to maintain the data dictionary or catalog information in PostgreSQL, okay, and PG underscore default table space, okay, this is useful, okay, this is useful and it is containing, okay, it is containing or it is for user data, okay. So PG global, we can call it as like in Oracle, if you compare in Oracle, PG global is equivalent to system or sysx table spaces in Oracle, okay, and PG underscore default table space is equivalent to user table spaces in Oracle, okay. Up to here, clear, guys? Guys, silent.
Yeah.
It means clear. Okay. Okay. So then we can jump into, or maybe before jump into customized table spaces, we can play something related to PG default. Okay. So PG default table space is useful to if you are doing any operations in PostgreSQL, okay, by connecting to the database, if you're creating any table, if you're creating any indexes, okay. So by default, those data, okay, those data will be stored under the PG underscore default table space. This is equivalent to user table spaces in Oracle. Okay. So what I will do now, we can jump into OIDs. Okay, the concept is like OIDs. Okay, OID. Okay, OID means object identifier. Okay, so what I will do, okay, so I will create, suppose I will create one a database. Okay, so I will create one database. Okay, DB1. Okay. So whenever if I create a database, okay, the PostgreSQL will allocate, okay, the PostgreSQL will allocate, okay, 1, 2, 3. Just I'm picking random number, okay. So I'm picking just a sample number, for example, okay. Whenever if you create any database in PostgreSQL will create one OID for that. Okay, one OID for that. Okay, that is the unique number that is managed by PostgreSQL internally. Okay, while creating the database, you are not mentioning any default table space. Okay, by default, this database will be utilized. Okay, okay, the space from the PG underscore default. Okay, in this case, so the directory, okay, there is no names under the like base directory, guys. Okay, so if you are using the PG underscore default table space, okay, if you create any objects, those objects information, it means database or table or anything index, okay, that will be created under the base subdirectory. Okay, you are using the PG underscore default table spaces and you are creating the databases, and you are creating the tables. Okay, like table 1. Okay, so then I can see like 2, 3, 4. Okay, so then if I create table 2, so then TB2, then maybe 4, 5, 6. Okay, guys, here I'm telling it's not like the same the number. It is like following. Okay, it is any number. Okay, that will be assigned by the PostgreSQL internally. Okay, so it means whenever if you create any database, okay, and you are not mentioning any customized table space, okay, by default the database will be use space under the PG underscore default table space. Okay, so whenever if you create any database, the OID, okay, this is a 1, 2, 3. This is the OID of the DB1. Okay, there is no name like DB1 under the base directory, okay, under the OS location, under the base subdirectory location. You can see the OID of the database. Okay, the OID of the database. Okay, under the OID is connected to the database and create the table. Okay, under the OID, okay, the table will be created. The table OID will be created. Okay, so this table OID, okay, OID initially it will created with 8 KB size. Okay, initially it will created with 8 KB size. It means in PostgreSQL, okay, the 8 KB size in PostgreSQL, that is the default block size or page size we can consider. Okay, so initially the table, okay, the table OID will get the space like 8 KB and it will grow until 1 GB. Okay, guys. Okay, it will grow until 1 GB. Maybe you have a question. Okay, 1 GB means very small file. I have a suppose 1 TB of the table. Okay, how it will manage in PostgreSQL? Yes, in PostgreSQL. Okay, how it will manage? You know, in PostgreSQL, suppose I have a 1 TB of the table. Okay, it will create. Okay, it will create. Okay, it will create 1024 number of OIDs. Okay, but how it will be relation, how the relation will be? Okay, the relation will be something like this. Suppose initially my TB1 size is TB1 OID is 234. Okay, so it will be create, it is if it is keep on growing, it will be create one, even after one, even that one also fit, then it will create 2. Okay, even that one also will, it will create 3 and so on. Up to here, clear, guys?
So these will be individual files, right? For each
Yes.
table, it will be a file. So the file name will be 234.1 dot something followed by.
Exactly.
Okay, will that have any extension to that, or it just a file name with the object ID?
And actually, see, the file name, so initially the object ID, OID, okay, OID will be created whenever if you create the table under the database. Okay, that is the unique identifier. Okay, that is a unique identifier that OID will be managed by PostgreSQL internally. So this file will grow. Initially, this file will grow until 1 GB. Okay, again, okay, this is 1 GB. You mentioned by default. Okay, by default, if you not mention any object identifier related information, okay, the file size is not other value. Okay, by default, it will pick. Okay, so 1 GB of the file. Okay, if you choose some other file size, suppose I don't want to have 1 GB file, I want to have different size of the file, maybe 5 GB and 10 GB or 20 GB. Yes, while initializing your cluster, okay, while initializing the cluster, there is an option to pick your data file size. Okay, data file, or I am telling the table file size. Okay, but in PostgreSQL by default 1 GB file will be created whenever if we create the table. Okay, once this 1 GB file is filled, okay, once this 1 GB file is filled, okay, automatically PostgreSQL will create, okay, PostgreSQL will create another file, okay, another file, okay, the original file name is 234, okay, and followed by extension is .1. Okay, even this file also filled, it will create another file, okay, it will create another file with the next number. Okay, then after even that also filled, it will create next number, so on, like that. It is clear?
Yeah, that is clear. One thing is, so the file will be the name of there will not be any other file name.
No.
There is no append. Nothing is appended to the OID as a file.
Appending is
It will be individual
number.
files in the
Actually,
OS level, right?
yes.
They will be just individual files at the OS level.
Correct. Actually, 234 is the individual file for table 1. Okay. And also 234 is growing like anything. Okay. For that, then it is appending with the number, unique number. Okay. 23.
Okay,
See,
got it.
if you identify these numbers, 234 is the OID of the table, and it is growing and it is allocating and it is appending the series of numbers 1, 2, 3 like that. I think it is clear for you.
And that is clear, yeah.
Okay. So, and this is, see, here we are discussing about the default table spaces. Okay. How it will be into the custom table spaces. We will see. Okay. Before that, so up to here is clear, right, for you guys? It means here, how it will be if you create any table, okay, under the database, okay, and it is not using any customized table space, okay, the data, the OID of the table file or OID of the data file or OID of the real file node. Okay, guys, I'm discussing here with 3 names. Okay, all 3 names are equal. Okay, how the location will be? So if we create the table, okay, then it will be like under the base subdirectory. Under the base subdirectory, we have the DB-OID. Okay, under the DB-OID, we have the table OID. Okay, it is something like that, right? Okay, this is the master base directory. Under the master base directory, we have the base subdirectory. Okay, if we create the database, okay, so the OID will be created under the base directory. Okay, if we create the table, okay, if we create the table under the like database, okay, so that particular OID will be created under the DB OID. Is it clear, guys? This path we will show you. We will show you in practical.
Yes.
Okay, so until now it is clear. Okay, this is we are discussing about the default table spaces. Okay, now we can discuss about the custom table spaces. Okay, global table space, this is no need to discuss. Why? Because it is containing the data dictionary or catalog information about the PostgreSQL clusters. Okay, so we can discuss about the customized table spaces. Okay, so why? Because in the real-time systems, definitely you need to use. Okay, definitely you need to use and you need to pick. Okay, default. The customized table space location to safeguard your data directory location. Why? Because the data directory is containing almost everything of the PostgreSQL cluster. Okay, even maybe if you ask, okay, the customized table spaces, I don't want to create in a default data directory location or not. Like if I'm able to create or not, maybe you have a doubt. Okay, yes, you can create the customized table spaces under the like base directory also, but the problem is if you're creating the like customized table spaces under the base directory, it will give the warning. Okay, so please choose some other location instead of the like data directory location. Why? Because this is the sensitive location. Okay, all cluster related files. Okay, the data directory locations, configuration files. Okay, on wall related information, catalog information, everything will be stored under the like master data directory. So the preferred thing is, even like while you are creating your like customized table spaces under base directory, it will allow. Okay, it will allow under the like data directory, it will allow, but the thing is it will give the warning for you. Okay, please choose your own customized location instead of data directory. That is just to safeguard your data directory location. Okay, data directory location. Why? Because it is containing the like very sensitive data. Okay, now the customized table space. Okay, we will discuss about like this one, PG_table space. Okay, you can see in the data directory location, we have the base subdirectory, and along with base subdirectory, we have another like subdirectory, that is the PG_table space. Okay, the PG_table space. Okay, so whenever customized table space means you are creating your own directory. Okay, you are creating your own directory, and while creating the table spaces, you are pointing out the location. Okay, at the time of creation of your table space. Okay, suppose if I pick this one. Okay, if I pick this one. Okay, this is my customized location, I can say. Okay, this is my customized location. Use U01 apps data something. Okay, yeah, something, anything is fine. Okay, so this is my customized location. Okay, so whenever if we create any customized table space, okay, any customized table space, to pointing the location of the customized table space is like this particular location. Okay, what it will happen, the OID of the table space. Okay, guys, like maybe suppose I'm creating customized table space this way. Table space, suppose TS1. Okay, and location, just I'm mentioning same U01 apps data. Okay, so if I create the table space is something like that. Okay, so here guys, as we mentioned, okay, if we create any component, if we create any object in the PostgreSQL, OID will be allocated. Okay, OID will be allocated by PostgreSQL, okay, and it is managing by PostgreSQL internally, okay. Here, if we create the table space, okay, a table space OID will be created, and table space OID will be allocated, okay. The OID of the table space will be created under the PG underscore table space location. Okay, suppose TS1 is my table space, okay, and a table space OID is 2, 3, 4, 5, 6. Okay, so this is my OID of the customer table space. Okay, and here what it will happen, it will have the symbolic link. Okay, it will have the symbolic link, and it is pointing to your actual location. Okay, you will see in the practical how it will be. Okay, so whenever if we create any customized table space, guys, this is the one important topic in PostgreSQL. This is one of the important topic if we compare to Oracle. Okay, so whenever if we create any customized table space, okay, the OID of the table space will be created. Okay, the OID of the table space will be created on the PG underscore table space subdirectory under the master base directory. Okay, and this OID will have symbolic link. Okay, OID will have the symbolic link and pointing to the actual location of your PostgreSQL table space. Okay, so here how the symbolic link will be created. Okay, so after completion of the symbolic link, okay, so maybe we can say there is a symbolic link. Okay, why? Because this is my the physical location. Okay, so it means the symbolic link will be like this. Okay, so maybe we can say OID of table space. Okay, OID of the table space. Okay, and then what it will happen, TS1 here I mentioned. Okay, and then so here there is a one other directory will be created. If you go and see in that particular physical location, we will show you. Okay, if you go and see the physical location, there is another directory. Okay, there is another directory will be created. Okay, will be created into the actual location. Okay, the directory name is something like the PG. Okay, the PostgreSQL, and followed by the major version. Okay, here we are maybe discussing about the 15. Okay, the major version of the PostgreSQL, and followed by the catalog version. Okay, the catalog version of PostgreSQL. Okay, we will show you how the catalog version we can find it for the PostgreSQL cluster. Okay, so under the particular location, okay, so the OID will be created under the PG underscore table space. Okay, OID will be created in the PG underscore table space. Maybe I can remove this one actually. So maybe you will be confused. How can I remove? Where is the eraser? Here is the eraser. Okay, I will remove this one. Otherwise, you will be confused. Okay, so customized table space OID will be created under the PG underscore table space. Then it will having the symbolic link pointing to the actual location of the table space. Okay, under this particular location, if you go under this particular location, okay, there is a new directory will be created. Okay, that the directory name is something like PG underscore your major version of the PostgreSQL cluster, and followed by and your catalog version of the PostgreSQL. Okay, this is the way it will be created. Okay, under here, suppose if you create okay any database, suppose if you create if you mention something like that. Okay, where is here? Yeah, here. Okay, if you mention something like create database, suppose DB2, okay, and table space. Okay, so if I mention TS1, okay, my default my customer table space is TS1. Okay, so while creating the DB2 database, I mentioned this database related data will be stored under the TS1 table space. Okay, so the table space is a logical, okay, and the table file is a physical. Okay, so in this situation, what it will happen? Okay, under the particular directory, OID will be create. Okay, DB2. Suppose I can say maybe 678. Okay. And then if I create, okay, suppose table 3, okay, 890, okay, and then table 4, okay, table 4, suppose 190, okay. So this way, where is here? Yeah. And also if we create another database the same way, DB2, DB3, suppose DB3, then table 5, okay, and table 6, okay, something like this. Then OIDs will be allocated automatically 1, 2, 3, 4. You can mention. Okay, just like, okay. So whenever if we are using the customizer table space, whenever if you are using the customizer table space, okay, OID will be the table space OID will be created under the PG_table space directory. Okay, and it is having the symbolic link pointing to the customizer location. Under the customizer location, there is a unique directory will be created based on our major version and also catalog version. Okay, so under this particular location, the table space, okay, the table space related, the database related OIDs will be created, okay, and followed by under the database OID, okay, the OID of the table will be created, okay, or OID of the index will be created. Okay, up to here, clear, guys? Any doubts?
I'm good.
Anyone? Any doubts?
One question. So
Yeah,
PG
please.
default and PG global. So it will be both will be created whenever you are creating the cluster.
Portuguese question. Yeah.
And custom table spaces, it will be. I mean, whenever it is required, then only you are creating that custom table spaces, right?
Yes, exactly.
Okay. And this is for the table spaces. It is for individual databases level or the complete cluster level.
This is for the cluster level. We are creating the table spaces, and you can utilize these particular table spaces for individual databases as well. It means if you create your database, if you create your table space at the cluster level, okay, so like this, okay, you can point out for individual databases as well. Okay, just direct answer to your question. Yes, table spaces at cluster level, it is useful for all the database in your cluster.
Okay, so any of the databases you are creating under cluster can be used any of the table spaces.
Yes. If you are not mentioning explicitly the customer table space, okay, the database will directly pick default table space.
Okay.
Got it?
Okay, got it.
I think this is that or someone. I am not.
No, this is Abhishek.
Abhishek, yeah. Okay, Abhishek. Okay, it is clear, guys. Maybe we can compare a couple of slides. Okay, then we can maybe jump into the demos tomorrow. Why? Because it will take maybe 40 minutes or 1 hour time. Okay, at least 40 minutes.
Only one question here. The BG
Okay,
global and default. We are saying whenever cluster is getting created, these two default and global tables are getting created automatically, right?
Yes.
So what is this? Is there any table space name? We have a database name called TIM01, TIM02, and default table database.
No.
Likewise,
The name the name itself, the default name itself, PG_default. The name of the global is PG_global only. You will see in practical.
Okay.
Yeah.
Understand. Thank you.
Okay. So maybe we can cover few of the slides and we can close it for today. Why? Because again, we will repeat the concept tomorrow. Why? Because we are playing with the numbers. Okay, it will get confused for you. Okay, so just 10 minutes discussion we can do tomorrow and we can complete the practicals. Okay, so we will cover some of the slides. Where is my slides? Okay, so guys, you are able to see my screen?
Yes.
Okay, so actually logical structures of a database. Okay, we already aware of. Okay, here in PostgreSQL, So the database cluster is nothing but a grouping of the databases. Okay, in each database containing the n number of objects. Okay, object might be table, maybe index. It might be the function. It might be the procedure. Anything. Okay, so like that is a unique word that is a common for any RDBMS system. Okay, in PostgreSQL, okay, in the PostgreSQL, okay, the objects, okay, the database object is like internally managed by the OIDs. Okay, so that we saw just maybe 2 minutes back. Okay, so this OIDs, okay, this OIDs is managed by PostgreSQL internally, and which is like dedicated and which is having the like 4 bytes integer values. Okay, so and the PostgreSQL actually in like as we mentioned, okay, in PostgreSQL every component, if you see the database, if you see the like user, if you see the table space, if you see like table, if you see like what else, like indexes, okay, any component in PostgreSQL having the object ID, OID and OID identifiers. Okay, so these OIDs internally managed by PostgreSQL. Okay, how it will manage and how we can pick that information by using the catalog views. We can pick the OID of your objects. Okay, suppose if you want to pick the like, or if you want to know about the OID of the database, we have the catalog view, that is the PG_database. Okay, from there you can pick the OID of your database. Okay, suppose if you want to pick the OID of your like table space, okay, then we have the like view like PG_table space in PostgreSQL. From there you can pick the OID of the table table space. In the similar way, if you want to pick the like OID of your like any table or any indexes, then we have the like unique the catalog view, that is the PG_table space. Okay, by using this particular catalog view you can get it. Okay, you can get the OID of the table or index. Okay, by using like this for each and individual like object in PostgreSQL. Okay, you have the individual catalog view. From there you can pick the OID of each and every component. Okay, this we already discussed. Just for recap, we have put this particular slide here. This one we already discussed. Okay, any doubts here from this particular slide, guys?
No, yeah, good.
Okay. Okay, this is what we discussed now. Okay, so here just we can recap, or maybe just we can like recall about, or maybe just for small information related to the Cloud SQL. Okay, in the Cloud SQL, first of all, if you're talking about like PostgreSQL on any flavor of in the cloud, okay, maybe in Amazon, maybe from like GCP, maybe from like Azure, okay, Microsoft Azure, or maybe from OCI or some other like cloud vendor. So most of the cloud vendors are now providing the PostgreSQL the database as a service. Okay, it means we don't have any access for the infrastructure. Okay, it means we don't have any access for any like OS location. Okay, to create the customized table space. Okay, it means if you are using your PostgreSQL cluster on top of any cloud, okay, we need to utilize, or we need to use the capabilities of the database as a service. It means we have only one option, that is the PG_default table space. Okay, all our data will sit under the PG_default table space. Okay, and there is no customizer concept in any cloud vendor related PostgreSQL databases. Okay, this is for your information, guys. Maybe in your real-time systems, definitely you will like work on the cloud related PostgreSQL flavors. But there, just keep in your mind, there is no customized table space concept. We have only 2 table spaces. Okay, that is the PG default and PG global. Global for like data dictionary, like catalog information, and PG_default is like the user related table space to store the user data. Okay, so actually this part we already discussed. Okay, the database cluster is having the like base directory, that we can call it as a like master directory in the PostgreSQL. Under the base directory we have the n number of like directories. Okay, and one of the directories is the base, and we are discussing here about the table spaces. Okay, the base is one directory, and PG_table space is another directory. This we already discussed. Okay, and this base directory we can make it. Okay, we can make it as a like environment variable, that is the PG_data. Okay, so this we already saw, right? Okay, so while playing with like PostgreSQL clusters, restart and like start and stop. Okay, we are using the PG_data. We said this is under the bash profile. Okay, this we already saw. Okay, so this base directory, you know, right? Okay, this is just a recap, guys. This we already covered in our like previous sessions. Okay, so this pg underscore data directory will be created. Okay, will be created. Okay, whenever if you are initializing your PostgreSQL cluster, then all these directories will be created. All these subdirectories will be created under the base directory. Okay, base directory. If you are not mentioning the base directory, by default PostgreSQL will pick under the var path. Okay, but as a recommended way, better you can create your customized like directory location and place it your like data directory location inside that. Okay, and this is this green table space. Okay, this is the concept here we are discussing from last maybe 15 minutes. Okay, this entire customized table space. Okay, nothing. See, if you don't have the customized table space, okay, there is no more discussion on this particular table space. Okay, why? Because if you create anything in the PostgreSQL cluster, okay, so the OIDs will be created under the base directory. Okay, so under the base directory you have the like n number of like database based directories. Under the base directories you can have, okay, you can have your object related OIDs. Okay guys, so this entire concept we are focusing more on the customized table spaces. Any doubts, guys?
Oh, good, Siraj.
Okay, so this one we already like discussed, covered, right? Okay, the term table space in PostgreSQL, it is different from other RDBMS systems. Okay, so okay, the table space is PostgreSQL is a one directory. Okay, that containing the outside of the base directory. Okay, this means we are discussing about the customized table space. Okay, customized tables means this is actually the base directory. Okay, this is like actual PostgreSQL like directory. Okay, a data directory. So we are pointing or we are creating symbolic link to some outside of the base directory. That is like your like customized location. Okay, and this diagrammatically we saw, right? Okay, so whenever if we create any table space, okay, the symbolic link will be created pointing to your customized location. Okay, under the symbolic link, okay, under the particular customized location, you can have the like pg underscore, okay, pg underscore your major version of the PostgreSQL and followed by like catalog version. Okay, under the catalog, under this particular like directory, you can see your database OIDs. Okay, under the each database OID, okay, the object related that particular the database OID will be created. Okay, guys. Okay, so as we discussed, there is no data file concept in PostgreSQL. Okay, there is no data file concept in PostgreSQL, but in PostgreSQL we have the similar file. Okay, we have the similar file, that is the table file, or that is the real file node, or we can call it as a like table file or data file. Okay, the name, everything is a common in PostgreSQL. Okay, so and also as we discussed in like I think Malati asked the question, right? Okay, in PostgreSQL by default 1 GB of the file will be created. 1 GB of the file will be created whenever if you create any table or any index. Okay, so it will grow like based on your like data insertion operations. Okay, it will grow until like available space into your storage, but it will grow. Each file will grow until 1 GB only. Okay, if that 1 GB file is filled, okay, as I shown you in the like paint, okay, 1 GB file is filled, so it will create the series of the files. Okay, and it is appending the unique number for the OID. Okay, to identify this particular OID belongs to this particular table. Okay, guys. Okay, so like this one we already discussed. Okay, the default and the PG global table space, we only two options are available in PostgreSQL cluster on top of the cloud. Okay, so guys, better we can close the session for today. Okay, and tomorrow we will discuss about we can do the recap for 5 to 10 minutes and we can start the practicals. Okay, is it fine, guys? Shall we close the session for today?
Yeah, fine.
Okay, any doubts before
Okay.
closing?
Yeah, one question, Sriraj. In the table spaces level, in the table spaces level, like the storage hierarchy, like the DB block will be the smallest unit in Oracle. Then after that, extent segments will be there.
Mhm.
So here, this kind of concept is available, or
Yes, we have the concept. Okay, so here how will be, okay, okay, so how here, let me minimize this. Okay. See, in the same concept is here the smallest OS block or DB block here is page. Okay. The combination of the pages we can call it as the table spaces. Okay, so there is no extend concept here in PostgreSQL. Okay, the page and top of the page, the combination of the pages, maybe we can call it as before that. Okay, we can call it as the table file. Okay, and the grouping of the table file, we can call it as the table space.
Okay, table file means that OID dot your number.
In general, if your table is like below 1 GB, okay, there is no dot, there is no value will be here. Okay, if it is under the 1 GB, then the file will be like a unique number. Okay, and it is more than 1 GB. Okay, so then the new file will be created automatically with PostgreSQL. And so on, it will be created until like you are storing the data into your table. Is it fine?
Okay.
We will draw the one diagram. Okay, we will draw the one diagram. Okay, while we are discussing about the page layout. Okay, so we will take you into very deep dive of the page layout. Okay, while we are discussing about the toast. Okay, and padding. Okay, there we will draw the like one proper diagram, like in what is the page and top of the combination of table files, and on the top of combination of table files is equal to table. Okay, and like inside the table, okay, how the rows will be stored. Okay, and we will give like one proper diagram. Okay, there you will get a better understanding. Okay, in the page in the diagram. Okay, so if no other questions, we can wrap up for today. Even I need to jump to some other thing.
Thank you.
Guys?
Yeah, thanks.
Thank you.
Yeah,
Thank you.
Thank you, guys.
Bye. Yeah, bye-bye.
Thank you.